Right, so we'll start in a minute, 1 or 2 minutes. Right, so while waiting for the others, do you guys have a question or a clarification so far regarding with your quizzes, activities, or past modules? Question, guys. So let's have this 2 to 3 minutes as your consultation time, okay, regarding with your lab 1, 2, and 3, and 4. Yeah, so do you guys have a question so far regarding with your laboratories? Hello, guys. You guys there? All right. So if you guys do not have a question or any clarification regarding with the last module that we have last meeting, okay, then let us now start with our victory module 4. All right. So let me just show this one to you guys. Yes, Miss Mabay. All right. So maybe she just accidentally press the mic. Okay, then. All right. So here's the overview of your module 4. Okay, so we have here the topic learning outcomes. So I hope that you guys have already read this one. Okay, and then here are the list of topics that we're going to talk regarding with this module 4. And then here are the learning resources. So as usual, we have here the PDF. And then we have here the video materials. So please do check those videos also. So they are very, very helpful when it comes to learning about number system. Okay, and then I have also prepared here an ebook. However, so there is a message. So it's okay, Miss Rubian. Okay, so this ebook is actually not the ebook that I am using before. Okay, so for some reason I cannot find the ebook, okay, that I'm using before. So I have found a new ebook wherein I think it's still helpful, okay, when it comes to learning about number system and number representation. Okay, so this is good for beginners. Okay, so please do check this one also if you are still confused regarding with the video materials and then with our PDF. Okay, and then here's one website. Okay, wherein I think this is one of the most complete. Okay, our introduction about number conversion or number system. So we have here these steps in how to convert decimal to other base system. Then here's the representation, etc., the other base system to decimal, and then the representation, and then the other base system to non-decimal, etc., to octal, to hexadecimal, and so on and so forth. Okay? So please do check this website also. All right. So yeah, that's it for the overview of your module 4. So any questions so far up to this point? Hello guys. Kumakain na ba kayo?
Yes.
You know? Are you guys there? Can you guys hear me?
Yes, sir.
All right. Okay, so if ever you guys have a question, so feel free to ask me anytime, right? And then again, so if you are already hungry and if it's already lunchtime in your place, so feel free to eat, okay, while watching or listening. Okay? So you can eat while uh, listening, of course. All right, so that's it for the overview. And here's the PDF. So please download this one now if you still don't have the copy so that you can have your own copy while we're having our own discussion. And then I have also prepared here 4 external links. So please do visit those practice exercise, for you to improve your analysis or how to, solve a conversion regarding with numbering systems. Okay, so those are 4 websites. So please perfect all of them first before, let's say, proceeding with the quiz next meeting. Okay, so since we only have 2 meetings for 1 week and one meeting is 8 hours, so yeah, I really need to finish this module right now. Okay, so maybe we will be able to finish this about at exactly 2 o'clock. I'm not really sure, 2 o'clock or 2:30. So it will really take us a very long time. Okay, so supposedly this will take 2 meetings. That's the normal way. But since one meeting is composed of 2 meetings already, as you guys may know, 8 hours. So we have to finish the module for today. All right. So once we're done with our discussion, then you may now proceed in answering those quizzes. And then next meeting, be prepared. Okay. So this is a very important announcement. Next meeting, you're going to have your quiz number 3 and quiz number 4. Right? So quiz number 3 will be, of course, taken from the digital safety and security or your module 3. And then quiz number 4 will be your module 4, number systems. So make sure to review the module 3 and then, of course, module 4 later on. Right? So are we clear with that one, guys? Okay, so you guys review, okay? So module 3 and 4, quiz next meeting, right? And then here's your lab number 5 and 6. So I hope that you guys have already checked this one. So for the lab number 5, you're actually going to create a letter. Okay, so this is just a 1-page letter. So this will only take you less than an hour, 30 minutes, 1 hour. So this is very quick to finish. And then the only hard part, or maybe so the difficult part on this one is creating a database wherein you're going to put here the information of your father, of your last name of your father, your last name, your first name, etc., etc. Okay. So basically, as you guys can see right here, we have some fields wherein it is enclosed with like last name, first name, title, last name, title. So do not type those texts, okay? Do not type those. You can create those from or just by following this instruction, okay? In that case, you will be able to have those merge fields, okay? Or a inserted fields, okay? And then you're going to create you're going to create a database. So that's another file that you'll be saving to your computer. And then this is another file wherein it is in the form of Microsoft Word. So basically you're going to submit 2 files, okay? One for the database and then one for the Microsoft Word file. Okay. So I would like you guys to submit 2 files. Well, to avoid having a complication like your submissions, just just compress that one into RAR file or what is the other one? RAR or zip file. Yeah, so either of those two, okay, as long as you'll be able to compress it as one file, okay? So you're going to submit it, okay? That's it. So any questions so far regarding with the lab number 5? Hello guys. Doon pa ba kayo? Okay, so if ever that you'll encounter a problem or any clarification in the future, so just let me know. Okay. So thank you guys for responding. I really appreciate that one because especially that I cannot see your faces. I'm not even sure if you guys are really in front of your computer or smartphone listening to me right now. All right, so that's it for your lab number 5. So just follow all the instructions and you'll be able to finish this one without a problem. And then here is the instruction of your lab number 6. So just better download this one, okay? Because the instruction in here is misarranged already. All right, so let me just show to you guys the lab number 6. So open that one on Microsoft Excel, okay? So down below, you will see 2 tabs. So the first tab is direction or instruction on how to, start tab number 6. And then the next tab will be the sample format, okay, of your tab number 6. So your task in here is, to be able to know on how to use the formula, okay, or the functions of your Microsoft Excel, okay? And then one more thing, this is in a lab mode, okay? You won't be able to copy and, modify this one. So this one is just a sample. So do not ask me why this one is lab. So this is just for your reference, okay? This is not for you to copy. So you're going to do everything, okay? The cell in here, the column in there, the colors, the tables, etc., etc. So you're the one who's going to create all of those. So the one that you're trying to practice here is on how to put a table, how to put that line, how to center that title, etc., etc. And then also, I should see formulas, okay, upon clicking this, let's say, sine, secant, tangent, okay? And then if I ever see a, let's say, just a number, okay, without a formula, then that only means that you have calculated that one using your calculator. So you should let the Microsoft Excel do the math for you, okay? All you do is put the formula, okay? Just put the formula and then let the Excel solve the following problems for you, okay? So in here, you'll be able to learn how to square a number, how to cube a number, how to square a number, and how to get the radius, how to get the circumference, how to get the sine, secant, tangent, cosine, cosecant, cotangent, and so on and so forth. All right. And then, of course, you're going to put here the formula used on each of those problem. So yeah, that's it for your lab number 6. So are we clear so far regarding with your lab number 6? All right. Nahihiya ba kayong gamitin yung mic nyo? So I think it is faster and easier if you're going to use your mic. So don't worry, lahat naman tayo dito is nag-umpisa sa pagiging mahiyain. Okay. So as time goes by, you'll be able to develop your confidence. Okay. If you're still quite shy in speaking mic. All right, so it's okay, Miss Dulay. All right, so that's it for your lab number 6, right? So the due dates of those laboratories will be on March 15. Okay, so you guys have exactly 1 week to do those laboratories. So for lab number 5, super easy, less than an hour. Lab number 6, maybe it will take you 1 hour, I guess. 1 hour to 1 hour and 30 minutes. And if you're having a problem, so just message me, all right? And I have also prepared here a case study, of course, case study number 4. So we have here the facts and then the question. Okay, so there's already one who have answered. Okay, so very good, Miss Agustan. So thank you very much for your quick response. Okay, so I'll let you guys read this one, read everything, and then just reply. Okay, and then tell us about your inputs for getting this one. Okay, so this is 20 points, and then the due date of that one will be on March 15 also. I wasn't able to put the due date. Anyway, but the due date of this one will be March 15, so exactly 1 week also. All right. So yeah, that's it for the quick overview of your module 4 and some of your laboratories. So any questions so far before we will start with our discussion? Answer. All right. So again, I encourage you guys to use your mic. So it is way, way better. Okay? I'm telling you guys right now. Instead of you guys typing, so it's it will take you longer to see your response. Anyway, so let us start now with your module 4 number systems. Okay, so as you guys can see, we'll talk about number systems only. And then here are the topics that we're going to discuss. So half of it is about number system. How do we convert decimal to binary, decimal to octal, decimal to hexadecimal, and base system to binary, and base system to octal, etc., etc. Okay, so you will learn how to convert a certain number into that certain number also. Okay, so we have 4 basic number system. Okay, so let me just give you guys a short idea when it comes to decimal, binary, octal, hexadecimal. So when we say decimal, the one thing that should come up to your mind when you say decimal in number systems is 10th base, okay, or base 10. So when we say base 10, it has a 10 characters or 10 values on that number system. But then again, in number system, we don't start with 1, okay? We always start with 0. So that is why instead of 1 to 10, this one has a value of 0 to 9, right? The same with binary. From the word bi, of course, it only composed 2 characters, okay? So in here, it's not 1 and 2, but we always start with 0, so it's 0 and 1, okay? So that's it for the binary. And then the other one is octal, wherein, from the word octal, so it has a base of 8, or it has 8 characters inside of it. But then again, we don't start with 1 to 8 or 1 and then to 8, but we always start with 0. So it's 0 to 7 only. So as you guys can see, if we have a base of 12, that's 0 to 11. If we have a base of, let's say, 15, that's 0 to 14. If we have a base of 16, that's 0 to 15. It's always less than 1 because we are starting with 0. Okay? And then hexadecimal here is or has a base of 16. So this one is ranging from 0 to 15. And then n base is just being represented by any other number system that is not decimal, not binary, not octal, or not hexadecimal. So those are like, we have base 4, base 5, base 6, base 7, base 9, base 11, base 12, and so on and so forth. Okay. Then after that, we're going to discuss about number conversion and operations. We're going to talk about sign numbers. We're going to talk about computer codes. Okay. So number conversion and operations are with the addition, subtraction, multiplication, and did I already mention division? So my mistake. We don't have division. So addition, subtraction, and then multiplication only. And then for the sign numbers, we're going to discuss on how you can put a negative number. It's a negative binary, okay? or negative hexadecimal or negative octal, because what we only have in a computer is positive numbers. Okay, so how about if it's negative? How do we represent that one using binary? Okay, and then we have here computer codes wherein is like the list, okay, of decimals, binary, hexadecimal, ASCII code, decimal, etc., etc. All right. So without further delay, let's start now with digital circuits. So from the word digital, so as you guys may already know, when you say digital, it only has two value, okay, wherein it is either 0 or 1, or on or off, okay? That is why digital circuits is binary in nature, okay? So it's always being represented with binary. So it's the common way to define a digital circuit, okay? But of course, several types of representations of numerical data are in use. So it's not only binary, okay, but mostly binary, okay? Sometimes it's also octal, sometimes it's decimal, sometimes it's also hexadecimal, but mostly it's only binary. So it's either 0 and 1, all right? So that's it for the digital circuits. And then one more thing that you guys need to know, why do we study about number system or binary or octal decimal or hexadecimal, is that's because this is how our computer reads the data. Okay, so as I have mentioned in our past modules, as I click letter A right now, it is not being read as letter A. It is being read as combination of number. Okay, so each characters on our keyboard, or any action that you will do on your keyboard, is being processed via number or via number system. So it could be binary, could be octal, could be decimal, or it could be hexadecimal. Okay, so that's how our processor reads the instruction that is being passed on to our processor. And then, of course, it will go back to the screen as another conversion. All right. So yeah, that's it for the short idea on what is digital circuits. And then we have here decimal number system. So just like what I've mentioned a while ago, once you heard the word decimal, the one thing that should come up to your mind is 10. Okay, it has a base of 10. So if it has a base of 10, it has a digit or 10 symbols wherein it's ranging from 0 to 9. All right, so digit is actually derived from the Latin word for finger. That is why decimal is connected with 10, because our fingers has 10 fingers, okay, or our hands has 10 fingers, right? So decimal base 10. And then we have here binary number system wherein I have mentioned a while ago, when say binary, it's only represented by 0 or 1. So 0 is actually for off or not activated. And then we have 1 as on, or it's activated, okay? But before we go with 0 and 1, so let's discuss this one first. Let's say we don't have one binary, 1 bit, okay? So binary has 2 bit, right? Because it's either 0 or 1 only. But a byte, okay, let's say right here, a byte is 8 bit, okay? Or in other words, which is in a unfamiliar way of, let's say, putting a unit on that one, which is nibble. Okay, so this one is might be new to you. So one nibble is consists of 4 bits. Okay, so when I say bit, it's represented by one character. Okay, so that is why 1 byte is equal to 8 bits, okay, which is this one. And of course, 1 byte is also equal with 2 nibbles, since nibble is represented by 4 bits. Okay, so just double this one, then you will get 1 byte. And then we have word, which is also unfamiliar to you guys. Wherein when you word, it consists of 2 bytes. Okay, and of course, 2 bytes is equal to 16 bit. Okay, so any of those. Okay, so you can convert this to bit, you can convert this one to nibble, to byte, to double word, and so on and so forth. Okay, and then we have here double word. So it's very obvious, just double the word, and then you will get here twice of the word. So 2 times is 4, so 4 bytes. So this one now has a total of 32-bit, okay, which is now the entire example of ours in here right now. So we have here the 1-bit, we have here the 1 byte. So this one is a total of 4 bytes. We have here 1 word, which is equal to 2 byte. And then we have here the double word, which is the entire example. All right. And then there is also one thing that you have to take note. So the most rightest part, okay, so this one, this is called the lowest bit. Okay, and then the leftmost part is called the highest bit. All right, so you guys will know later on why this one is your lowest bit, and then this is and why this is your highest bit, right? But for now, here's the representation from the decimal to binary. All right, so we have here 0 as a decimal, and then we have 0, 0, 0, 0 as the binary. And then we have here 1, which is 0, 0, 0, 1. We have here 2, which is 0, 0, 1, 0. Now, how did we get those binary combinations? Like, yeah, you guys can understand what is 0, 1, 2, 3, 4, 5, 6, up to 15. But how do we get those 0, 0, 0, 0, 0, 1, 0, 0, 1, 0? Okay, so let me just show this one to you guys for you to have an idea on how did we get those binary combinations of numbers. All right. So the so let's just start with 4-bit. Initially, we have a minimum of 1 bit. Okay, we have even 2 bits. We even have 3 bits. We even have 4 bits, and then after 4 bits, this one now is 8-bit. Okay, so that's the normal way of arranging a bit. So having 1 bit or 2 bit in our computer is very unusual because this one can only represent 0 or 1. This one can represent 0 to 3. This one can represent 0 to 7. This one can represent 0 to 15, and so on and so forth. So as you guys can see, let's say we have a base of 3 and below, okay, then you can have up to 3 bit, 1, 2, or 1 bit or 2 bit or 3 bit, up to 2 bit only, sorry. But if we have a, let's say, 4th base and above, okay, so that is now the time, not really. 4th base is 4, 0, 1. I'm sorry. Okay, so if it's 1, 2, 3, 1, 2, 3, I don't know, that's correct. Okay, so if we have 4th base up to 7, okay, sorry, I forgot to put here 7. So that is being represented by 3 bit. Okay, but the normal one is always 4 bit. Okay, so we will use 4 bits in terms of a binary conversion. Okay, so when it comes to octal, we will use 3 bit only. When it comes to 3rd base, then we will use 2 bit only. If it's 1 base or base 1, then we will use 1 bit only. But normally, this is the common counts of bits when it comes to representing a number. All right, so enough with those. Let us now continue with the decimal to binary. So we have here 4 bit. Okay, so this is your lowest bit, and then this is your highest bit. All right, and then each of those bit is representing a decimal value. All right, so what are those decimal values? So the lowest bit contains a value of 1. All right, and then the second bit is 1, contains a value of 2. The third bit contains a value of 4, and then the fourth bit or the highest bit contains a value of 8. All right. So if you're, let's say, if it's asking you to have a decimal value of, let's say 10, okay, and then it wants you to represent it in binary. So 10 can be done by having this combination. So oops, 1, 0, 1, 0. So why 1, 0, 0? Okay. That is because you have to activate or you have to turn on this one, the highest bit, which is 8, and then the second higher bit, which is 2. Okay, so 8 plus 2 is equal to 10. So that is why this is the representation of 10 in binary, 1, 0, 1, 0. So if it's asking you to have, let's say, 5, then you have to activate 4 and 1. So in that case, 0, 1, 0. Yeah, so 0, 1, 0, 1. So this one has a value of 5. So of course, if we have, let's say, 0, 0, 0, okay, so this one is 0. If we have 0, 0, 0, 1, this one is 1. If we have 3, 0, 0, 1, 1. If we have 2, then it's 0, 0, 1, 0. What else? If we have 8, so 1, 0, 0, 0. And let's say we have 15, okay? Then just activate everything. So in here we have 1 plus 2 plus 4 plus 8 is equal to 15. Okay, so that's how we represent those decimals into a binary number. So were you guys able to follow so far?
Yes, sir.
Okay, so you guys do not need to memorize this one. All right, so do not memorize this one. The only thing that you need to memorize is this one. Okay, as long as you know that the first or the lowest bit is 1, second one is 2, 4, and then 8. Actually, it has a pattern. All you need to memorize is this one, okay, the lowest bit. And then it will keep on increasing, okay? So how did we get 2? So just multiply the last number by 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So if ever we have, let's say, fifth bit here, fifth bit, or up to, let's say, 8 bit, okay? So this one is 16. So just multiply this one by 2, so 32. 32 times 2 is 64, and then 64 times 2 is 128. All right? So this one is 8-bit, and then if everything is activated, this one is equal to 256, I guess. Yeah, if I'm not mistaken. So 256 in terms of decimal value. All right? And then if ever that there is more, let's say it reach you up to 12-bit, okay? So just double this 1128 will become 256. 256 plus, 256 times 2 is 512. 512 times 2 is 1024. And then 1024 times 2 is 2048. Okay. So yeah, it's actually infinite. So you can have as many as many data as you want. Okay. No matter how large it is, you can represent it using a binary number system or binary format. All right. So are we clear so far?
Yes, sir.
All right. So how about the others? Were you guys able to follow?
Yes, sir. Yes, sir.
Yeah, very good. So if you guys have a question, so just let me know as soon as possible. Okay, very good. So we have here octal number system. So from the word octal, of course, it has a base of 8, wherein, of course, it has a range of 0 to 7. Okay, and then here's the representation from the decimal to octal. So 0 to 7, decimal to octal is the same. Okay, so nothing happened. But when it comes to 8 of decimal, it will jump to 10. Okay, that is because in octal, we don't have 8 and 9. If we don't have 8 and 9, we don't also have 18, 19. Okay, you don't have 28 and 29. We don't have 38 and 39, 48, 49, 58, 59, and so on and so forth. Okay, so that is why from here, you will add 2. Okay, so 8 in decimal, just add 2. Okay, so since we don't have 8 and 9, so it will jump to 10. Okay, up to 15, so just add 2, then you will get 17 in octal. And then when it comes to 16, okay, 16 to 23, you're right, 16 to 23, 7. Yeah, 16 to 23, just add 4. Okay, so that is why, or that is because we have already skipped the 8 and 9, 18 and 19. So just add 4 in octal. Okay, so 16 plus 4 is 20. If we have 17 in decimal, we have 21 in here. And so on and so forth. Okay, but don't you guys worry. Mostly we are only reaching up to 15 in terms of decimal. Oh yeah, sometimes we are reaching up to 16, but that is very, very rare. Okay, mostly it's below 7 when it comes to octal, or up to 10 maybe, or up to 12. Okay, but that is very, very rare. All right.